Welcome to everybody to the webinar on intelligent packaging regarding Work Package 5 in SUREFISH project, regarding with the training modules that we have planned for Work Package 5. So the training module is going to focus in intelligent packaging and is going to lead by me, Nuria Herran from ITENE, and Carmen Toledo, my colleague, also from ITENE. Okay? It's a general overview about what is intelligent packaging, and if you have questions, you can interact, and it's a webinar to learn about these issues, and it's up to you to ask. Okay? The points of the webinar will be around introductions to traceability and what is intelligent packaging, smart packaging, the cold chain traceability issue that it's very important in SUREFISH project, technologies that you can apply to packaging, and we have a study in Work Package 2, and we want to launch in Work Package 5 in the pilots for the companies. The integration methods, application, and examples that you can find in the market, and also some labels and these kind of things. And finally, a conclusions of this webinar. About traceability and intelligent packaging. Traceability is a concept used in industry to track the entire supply chain, to track products, and we can apply from raw materials to a final products that arrive to a company or a shop, a final distribution point, etc. The traceability of a product helps to know information very rapidly. We find what information, what is the product, to identify the product, the name, the model, the identification, the ID of the product, the composition, the processes, the batch, the reference, etc. This is the traceability is used for what I want to trace, when, to locate the item, the specific time and date, the specific order or shipment, also the expiry date, where, to know the place of the manufacturing product, the place from it sent or arrive, etc. And why, to know the reason, the state of the product that performed. The traceability is an issue that know information about what, when, where, and why. There are different types of traceability. We have bottom-up traceability, process traceability, and also downstream traceability. The bottom-up allows to know in detail the origin of the raw materials, for example. The process traceability includes the data obtained during the transformation processes from raw material in an industry. For example, we buy cotton, and afterward, with this cotton, we convert in a sweater, in a jersey, for example. That this is the process traceability, and also the downstream traceability that covers the logistic process, the distribution of the products, the end customer, etc. And this is more our downstream traceability is our traceability that we have focused in SUREFISH project. Okay, that one, the 3 point. Regarding the bottom-up traceability, refers to receipt of goods, records the key trace of movements, the product back of the origin or from any point or previous stages. The information that should be recorded about the bottom-up is from whom the goods are received, what exactly has been received, and when the goods were received, and what was done with them when we resell. We have some examples here. The first one is the origin of the goods. The second batch, the second refers to the batch number, identification of the batch, and and the finally is stored in warehouse X or what this kind of things information. Process traceability relates the products that have been received in a company, the operation or processes that have followed in a company. For example, in SUREFISH project, the fish companies take the fish product in the boat, and the boat goes to the company. And this kind of process traceability, the company manipulate the fish products and deliver to a market or to a specific place. So this kind of process traceability is here. And the information that should be recording when the products are split, changed or missed, what is created, from what is created, how and when, etc. And downstream traceability is what and to whose the products are delivered. From this point on, the products are out of the company controls. It's when the company packs and delivers the products. The information that has to combine is to who is delivered, what exactly has been sold, when, the transport mode, etc. And special mentions is when in consumer distribution companies, it is not necessary to keep detailed records from individual customers, but is useful to have control. So this is more or less the different types of traceability. As I said, we focus in the process traceability more in SUREFISH project, but to have all detailed information, this is more about traceability, the 3 points. Bottom-up traceability, process traceability, and downstream traceability. Regarding food loss legislation, also traceability is a useful tool to track products and to know information, as I said, but it's always also we have to follow because it's regarding food legislation. We have from 2022, we have the European regulation about traceability and vertical regulation depending on the products, and we have to follow traceability because it's a legal issue also, and it has a lot of advantage if we link to cold chain as this project, SUREFISH, etc. But we have to follow due to regulation issues. Why traceability in the food sector? As I said, is a legal issue, but also the free movement is and safe of food is an essential aspect in the market. Food safety requirements do not differ significantly from one member to another. Have you any questions? Please, could you mute your microphones if you are not asking? ¿Los has muteado? Okay. Okay. It's good to track the products because trace the origin, identify the business of the food supply chain, and also feed animals or substance depending on the product. Ensure the traceability in all states as is a legal issue. You have following the traceability ability to trace and follow the goods, and it's a critical point for consumer, also for consumer protection and perception. And also traceability is a management tool to avoid risk and to have everything under control. And if you have some incident, to deliver, to know about the different batches and release from the market. I mean that, for example, when in a food industry has has a reclamation on market because some products are not okay, they rapidly, due to traceability, take out of the market. That's it is important for legal issue. The application of traceability system has a very ranked advantage for economic and for consumer administration and legal issues, as I said. For companies, includes security and economic benefits. You have several points here to support when the problems arise, to enable a decision to be taken rapidly, making due diligence if something occurs, etc. For consumer point of view, increased confidence because they have the same time that the product has the appropriate transparency and information through the entire food supply. It guarantee if any problem can arise, we rapidly make a decision and we can take out from the market. And from administration, as I said, to avoid the incidents and also for control and legal aspects. Traceability is important, but you have to manage with the tool you want to use. Nowadays, the more widespread point is that the QR codes, barcodes for the products. This is the more extended because for traceability. But also the company want to is open to use the technology they want to use. They can use the barcodes, but also they can use QR codes or RFID. You have to follow the traceability of the products, but you can choose your own technology to use. And regarding intelligent packaging, it's the definition you can find in a reglement, in a European rule, that it's a 1935 reglement in 2009, and regulates what is intelligent packaging and also what is active packaging. Intelligent packaging is a type of packaging that is able to monitor what's happened to the product along the food supply chain, okay, along their supply chain, but not interact with the product, only tell you, monitor, control what's happened, but that's all. It's intelligent because the packaging can tell you what's happened to the product, but that's all. For example, if the temperature has a build, the packaging has a TTI or a data logger, and and they tell you if the temperature is abused, but that's all. You know the temperature. And I like the distinction in intelligent packaging. You can have a packaging that transport information, and you have to use a RFID reader or an optical reader. They only transport information. You don't see the information, but you can see with a special device to read it. This is intelligent packaging that transport information. And also you have another type of intelligent packaging that has a visual indication, only show the information to you. It has visual information. For example, freshness indicator, time temperature indicator, leakage indicators. They are indicators that change the color in a visual way. And this is also an intelligent packaging that tells you that the freshness is not the appropriate, the time temperature has abuse, but you only have this information with a color change. So intelligent packaging gives you this information through a device transporting has a barcode, a QR code, an RFID tag, an electronic sensor that you can read it with a reader. And that's a type of intelligent packaging. And the other type of intelligent packaging is a visual indication. And you have the information by visual indication. So in the webinar, we are going to follow different examples about devices that transport information and other labels or devices that has a visual indication. Okay. So first of all, we want to highlight the cold chain traceability. The important point is a necessary methodology for preservation, distribution, and management of the product, especially for food products or perishable products. And for the cold chain, the critical factors are moisture, temperature itself, along the time. This is, for example, a chain model, the manufacturer, the internal transport, the storage, the later in a food industry, later manufacture, transport the products, distribution platforms, also transport and going to the shops or the retailers. This is an example of main actors of a food supply. We have the different food supplies in SUREFISH, mapping in different deliverables. And the critical points along the supply chain in the cold chain is the important points are waiting times in loading and unloading process. But when we load the truck in a factory or in a house, it's a critical point. A long transport distance can be along by road, for example, is also a critical point because something can happen along the time in the transport. Also the last mile, because most of the times the long distance transport arrive to logistic platforms, and then from the logistic transport go in different vans. For example, this is the last mile distribution transport. So also is important to look at this, and distribution to reach the final consumer also. This is different of the critical points. The common temperature control along the supply chain, in the factory, in the warehouse, we have continuous temperature controls. Before loading onto a truck, we control some random products because we make different trials to know if the product is okay. During the transport, refrigeration temperature control systems, we have to fulfill that the transport is well prepared to preserve the food product. And also during truck unloading, depending on the distribution platform or the client, sometimes they perform random control of the products in order to make us a sensor and stick it on the product, and yes, it's fresh. It's around 0 degrees, 2 degrees. It's okay. Okay, right now, do you have some questions about intelligent packaging, traceability, critical points in transport and in traceability? Now we are going to focus in technologies to apply to packaging to make intelligent, okay?
Okay.
Yeah, as we said, adding elements to a packaging, printing sensor or sticking labels can give useful information to consumers. It's the intelligent packaging issue. As I said, you have intelligent packaging transport information with application that only transport information, and you have to read it by lectors, by readers, and then another types of visual indication. And now, okay, excuse me. Okay, the value for market and the technologies applied to packaging give a good value for market and the society, okay, because complete control of the cold supply chains and make manufacturers confidence, customer confidence. You have this is good. The visual indication, you have an immediate indication of something has happened. Also, they have to be easy to understand and interpret for consumers. And for example, in the case of TTIs, provides thermal traceability sensitive products. For indicators, for visual indicators, the different markets, also for intelligent packaging, is food industry, pharmaceutical or health sectors, vaccines, nowadays COVID vaccines, also medical instruments like ocular lens and hair balls, for example, blood container, plasma. It's also very important and critical sectors to monitor what's happened, diagnostic kits, for example, and also different chemicals that are sensitive to something, to a critical issue, okay? And these technologies to apply to packaging, to make it intelligent, have a great potential in the food sector. Regarding transport information, regarding the devices that you in the packaging, you only has the barcode, the QR code, the RFID, the NFC tags, or other sensor. You don't directly, you have this device on the package, but you are not able to see nothing. You only has to read information if you use a smartphone or a reader or an optical reader or wireless reader. That's the point of the devices that transport information. The barcode is a group of lines of different thickness and placed in different distance for each other, and which together contain a specific amount of information. As I said, is the widespread tool for food items. And here you have the functions of the barcode: provide product information, identify country and manufacturer, follow up on products. Benefits is identify the rise and fall of product sales, track inventory, etc. And the applications in retail shops to sell products more easily, because the cashiers, they read the barcodes or the prices depending on, and have the information, real time, accurate tracking, etc. This is the barcode, and as you see, the beginning, the numbers in the beginning of the left side said it's regarding the country. Later on is regarding the manufacturer code. Later on is the product code, and finally a checked digit. Okay, this is more or less that barcode is made. We have a lot of type of barcodes. They using the EAN, UPC, code 39, code 128, ETF, okay, depending on if they are used for transport industry to identify boxes in a system, or is a symbology to use a transport industry, or is more related to food industry, or even with the country. In USA and Canada is also UPC, and more widespread is in Europe is EAN. Okay. Also, this is the conventional traceability issue that is widespread, but little by little we see PFF 417, okay, in some countries, QR codes, like we use in SUREFISH project, in the platform that INGE developed, but also you can find data matrix, here's GS1 data matrix. As you can see, these are type of barcode, but using 2 dimensions to the barcodes. The advantage or disadvantage of using barcodes or 2D barcodes you have here. 2D barcodes allows encoding more characters than a linear, and the reader can read in different angles. This is the barcodes, you read it with an optical reader, and depending of the light, you have more challenge to read it or not. That's the point, for example, in that differences from RFID technology, that is a wireless technology we are going to see afterwards in the presentation also. QR codes, data matrix codes, here you have different characteristics of different, it depends on the application, it depends on the industry you want to use, but here you have a summary of different ones. Okay, QR codes are more focused in consumer and marketing applications because they are very well related with smartphones, for example, and data matrices are more focused in industrial applications, for example. This is information about barcodes, technologies that has to read it by optical readers. The RFID technology is a radio frequency identification technology, is an electronic method of identification a code to a product using a silicon chip. As you can see in the photo, you have a chip here in the center, a silicon chip that has the information of the product, and this silicon chip is attached to an antenna, and this confers a label. This is the RFID label, okay? And you read the information with an RFID reader that is a wireless reader, okay? And this type of technology is not optical, it's wireless, but it's more expensive because you need infrastructure to use it. You need an antenna, readers. We are going to see right now. The different components of our RFID system, as I said, is the label, the RFID tag, the RFID label, but this label has to exceed for a RFID antenna. The antenna make a wireless communication with the chip that activate the chip by to be read by a reader, and this all this information is placed in a host computer. Okay, the tags, the antenna make a signals that active the RFID chip, and the scanner or reader is able to read the information of the chip, and then you all the information of your different RFID labels, you can have a host computer to have all the information. So the tag has a integrated circuit and antenna, okay, and this is the RFID label. For RFID, you have different labels: passive tags, semi-active tags, and active tags. The difference of the RFID label is if they have a battery or not. The active has a battery, an internal energy source in the label that sometimes is good to have some specific sensor for temperature, and also they are more expensive. Semi-active tags that is a mix between passive and active tags, And the passive tab is only the silicon chip with the integrated circuit applied to the antenna. Okay, and this is the cheaper one in the RFID technology. Depending if they have battery, the power, and also the different the frequency they read by the reader. For example, low frequency has this terahertz, high frequency, ultra high frequency, and microwaves, depending on the frequency. And depending if they have battery power source, they are cataloged, they are classified as a passive, semi-active, or active. And depending on the frequency, they are also classified in RFID low frequency, high frequency, ultra high frequency, and microwaves. For example, low frequency is when some RFID readers, you have to you have to be very close to the RFID tag, because it's not very it's not a barcode, but you have to be very close to the RFID tag to be reader. High frequency, ultra high frequency are more in logistic issues that in logistic platform that you have you can read the products, but with a lot of meters from the reader. The scanner or the reader reads and decodes the information from the RFID tag chip and sends to the system. For example, when you need the smartphone or the reader specific to read the RFID tag. The antenna is an element that is necessary to make the electromagnetic field to activate the RFID tag, the passive, the semi-active, or the active one also, to be read. Okay, and this is, for example, as I said, the ultra high frequency. You have to be, you have to read products around 3 meters. The other are closer. Why RFID is also in competition with barcode. Barcode is well widespread because also it's cheaper than the RFID, because when you use RFID, you have to apply RFID tags to all the products. You have to need the antennas, you have to need readers, and you need an infrastructure that in QR codes are widespread, not in RFID. But RFID is a wireless system that is more rapidly to identify the products. As you can see here in this slide, the barcode is an optical technology that needs visibility to work. You have to put the optical reader to read information, identifies a type of product, not a unique product, only a group of product, and also depending on how is the logistic, but sometimes can damage or something like this. And so that's the reason that the RFID is on the market also for a specific application, because over time overcomes this limitation, but it's more costly. The advantage of RFID technology from barcodes is no direct light of sight is required. You can read it. You pass a palette around the antennas and the scanners, and you read all the products that this palette has. Labels can not only be read, but they can also be sent information to the recorder. You read the information of the silicon chip on the palette, and this allows the traceability of the product in an automation optimization of the processes due to the rapidly of the process. Okay, increase reproducibility, can reduce errors, and it's And this is a point, but the other disadvantage is that it's more costly technology, because you need this infrastructure of readers, antennas, apply the labels for each product, and these kind of things. As I said, you have the limitation of the RFID technology is the cost of the technology itself. But depending on the application, you can make a return of investment. You can calculate the ROE, the return of investment. For example, in textile application, in clothes, Zara clothes, they have RFID for the logistics processes. Every unit and interface and internet is required. For metal or liquids, some interferences with the wireless can be fine. It's not a perfect technology. For example, for conductive materials, metals, and liquids, you have a limitation of reader with the readers and using this information. And also you have the interoperability. You have to follow the standard, the regulation. If you apply to your products but arrives to a logistics platform that is not prepared with RFID, it's not worth to. We need that the whole supply chain use RFID to be more interoperability and to be more useless or useful at the end. Here you have different, in a table, different points of the barcode with RFID. For the barcode, as I said, is a optical reader, but in RFID with the wireless technology, you read very rapidly, and more or less, as I said, is a barcode. It's a slow tracking system if you compare with RFID, but the RFID is more. It has more cost, and also the logistic chains has to be well prepared in the different areas. Other devices that can be applied to the packaging is for example, the data loggers. You can read the information with reader in a data logger, or also in a displays that they have the information. They are record information and give you the information over a period. And also this is, for example, a specific device that we have developed here in ITENE about the vibrations. Depending on this device, you put on a box, on a pallet, and record the vibrations of the product. And due to this vibration, you can optimize the packaging. For example, if depending on the distribution transport mode, you know the vibration, the accelerations, and you know what is the best packaging to use depending on how is the transport. It's also a type of sensor. Okay. You have, for example, specific e-button, specific data loggers, very small or not. You have to incorporate different sensors inside about temperature and control the temperature during the supply chain. And more or less, this is about the devices that transport information, give you information, the barcodes, the RFID, sensors, but you need a reader to know information about this product. On the other hand, we have the visual indication for packaging that is also labels that give you information, and now are going to, my colleague Carmen is going to explain this kind of indicator.
So we have this type of tools are commonly known as indicators, and they can be for freshness indicators, time temperature indicators, leakage indicators, or others. We are going to see how they work and also some examples. But first of all, there are some characteristics that are required for these types of indicators in terms of operating mode, security, manufacturing, and cost. Regarding the operating mode, it is important that these indicators, the response that they show is irreversible and also influenced by packaging conditions. This change in color has to be obvious to the visual perception and also has to be easy and quick to read and to understand for the person who is reading. Also about security, they have to be non-toxic and compatible with food contact legislation, also compliant with packaging waste legislation, and its response has to be reliable. About the manufacturing and storage, normally these type of indicators are made in form of labels that are easily applied to the packaging, but they can also be applied by painting or coating. It is important also that they don't need a special treatment to be manufactured or to be used. Also, its reactivity has to be unaffected by the storage time. The cost is also important. They have to be as cheap as possible. Also, it's important that we don't need a special equipment to use them, and also that the visual reading is done without this instrumentation, this special instrumentation. We have to be able to read the response with the naked eye. So some reasons for using these indicators is because food safety and hygiene legislation is getting stricter by the day, and these indicators are a safe tool and give us to clients and consumers, they give confidence. Also bring commercial benefits to the producers or distributors that use them because they allows them to differentiate from the other producers that are not using them. The first type of indicator is the freshness indicator. In this case, these indicators provide information on the quality of the food product from biochemical changes of growth of contaminated microorganisms. Examples of metabolites that interact with that the indicators detect can be glucose, CO2, organic acids, volatile compounds, biogenic amines, and the changes in the concentration of these metabolites are generally observed as a change in color in this label or indicator. And this change of color can be correlated with the freshness of the product. So the reaction between these metabolites and the indicators is within the packaging system and presents visual information about the microbiological quality of the products. And most of these indicators are based on pH changes due to the presence of specific metabolites or changes in the gas composition in the packaging. And it's also normal or it's preferable to use natural coloring agents in terms of food safety because these labels are applied to the packaging of food products. This is an example of a freshness indicator. It's named FreshCode and it was developed here in ITENE in a scope of a project in collaboration with other companies. In this case, the indicator is placed at the interior of the tray and it captures the emission of volatile gases released during the spoilage of the chicken breast in this case. So in this level, the intelligent ink gradually changes its color from white to black to indicate the level of freshness of the product. So when the inner circle is darker than the outer circle, it means that the product is unfit for consumption. Sí. Sorry. This one is another example of freshness indicator. It's called ripe sense. In this case, the sensor changes its color by reacting to the aroma or volatile compounds that are released by fruit as it ripens. So this sensor is initially red and gradiates its color to orange and yellow. By matching the color of the sensor with the eating preference, customers can choose what type of, if they want the fruit more mature or not. This is the second type of...
For freshness indicators, they monitor the metabolites of the deteriorations, and it's needed an individual packaging like this or like this, because it's not for bulk containers, or you need a closed atmosphere to monitor the freshness, the spoilage of specific products. So it's important to remark that the freshness indicator, not from the point of view of time temperature abuse, it's from the point of view of deterioration of the food products. You need a specific individual packaging because you need this atmosphere to monitor this headspace. Okay, and that's only to remark this type of freshness indicator.
Yeah, it's perfect. So there is the second type of indicators. There are the time temperature indicators. These tools or device display an easily measurable time temperature dependent change that cumulatively indicates the time temperature history of the product from the point of manufacture to the final consumer, in order to detect or improve critical points in the cold supply chain. These indicators do not provide quantitative information. For example, they don't give you the information of temperature in a determined time or the concentration of a determined compound. And they do not store measurement of time data. They only show immediate visual and qualitative information about the packaged food by a color change, but they don't store information. There are different mechanisms or modes of action of these for these indicators via enzymatic reaction, microbiological growth, polymerization reaction, or by capillarity, but all of them give a response as a color change in the indicator. For example, this is one TTI that works by an enzymatic reaction. This is an inner bag with two components, an enzyme and a dye. You have to press the compartments and mix them together to put in contact the enzyme and the dye until the content is green. Also, this enzyme is only activated above a given temperature and cause the dye to change its color, for deep green to bright yellow, or also finally red or orange. These labels are formulated to coincide with the shelf life of the products to inform if there has been an adequate refrigeration during the distribution chain. And also the response inform us if the product is suitable or not suitable for consumption. You have there an example of how the color changes in time, and they have to be stored frozen because it's an enzyme that can be its shelf life is I don't know how to say.
Expired.
Yeah, in order to the enzyme to be able to work.
Yeah, from green to orange.
Yeah, you can store it frozen or refrigerated if you want more or less shelf life. So there are this type of TTI based in a microbiologic growth. It's based in a time temperature dependent pH change caused by the controlled microbial growth of selected strains of lactic and lactic acid bacteria. At the determined temperature, the bacteria starts to grow and the metabolites that this bacteria produce cause the color to change. So this is how the color changes from green to a pink or purple. And this one was initially commercialized as the EO1 from on the left, and then evolution into the right one, the top cryo. Here we have another example of TTI that functions by polymerization. In this case, the combined effects of the time and temperature cause a gradual, predictable, and cumulative color change from light to dark due to the polymerization of a component that is in the label. This label is specifically formulated to match the shelf life of the food products. For example, they have different types of labels in order to monitor the product that you want for fish, for meat, or other products. Also, in this case, the center of the label changes color by giving this dark color, and it's irreversible darkener and make it easy to see when you can use or not use the food product. When the color changes, so the color inside the inner circle is darker than the color outside, it means that the product is unfit for its consumption. This type of label have to be stored frozen, and it does not need activation or conditioning. There is another type of TTI indicators that functions by capillarity or diffusion. These indicators are composed by an ink that flows down the indicator strip when it's exposed to a certain temperature. This label monitors the temperature and indicates if the product is exposed above this chosen temperature and for how long. When this temperature is exceeded, in the label appears an easy-to-read signal in a form of a color-based response that estimates the total exposure time about the temperature that we are selecting. These type of indicators are used to control any product sensitive to time temperature abuse, and are used mostly on secondary packaging for distribution. Also, it's important to note that this type of indicator control the temperature exposures, not product quality. You need to verify that the quality of the product it's okay or not, because this only gives you information about the temperature exposure. This is one example of TTI that functions by capillarity, the monitor map. This type of label is inactive in storage at room temperature, and you only have to manually activate it by removing the activation strip here at the left end. And this, when you remove this activation strip, you release the ink, and this ink is in contact with the paper that is inside this label. So if the product is in a temperature above the threshold temperature of this label, the ink becomes liquid and flows through the label until it arrives at its stop temperature again. For example, for a label of 5 Celsius degrees, when the temperature is above 5 degrees, the ink starts to run through the label, and when it's below 5 degrees, the ink stops because it's solid. And when these are different types of temperature and detector times, you can purchase the one that is most useful for you. And also, these labels need a conditioning phase below the stop temperature before removing the activation strip and placing it in the packaging. It's self-adhesive. Unless the product is already below this temperature, because if you don't do that, it can be a premature response.
We have tested in SUREFISH project this type of TTI in simulation labs.
And this one also.
And also time strip plus label have also validated in SUREFISH project.
In this case, the label is also inactive in storage at room temperature, and you have to activate it by pressing a button with the ink, and you release the ink and put it in contact with the label. You have to press the button and wait until the word on appears in the window. And also, if you are not going to use the label immediately, you have to store it at a temperature that is below his stop temperature before sticking it to the packaging. Or if the packaging is ready to be distributed or is in a condition or a correct temperature, you can already attach it to the packaging and send the order or the delivery of the products. And this is the last type of indicator, leakage indicator. The package integrity of the product is an essential requirement for maintaining the quality and safety of the food products. Also, the indicators for indicate integrity, the most commonly used are gaze indicators in packaging applications. And these labels react in response to change in the internal atmosphere of the package. So this variation in gas composition induces a color change in the label. And this color change could be attributed to improper sealing of the package, leakage, or tampering. This is an example of this type of indicator, H-less type, that it's pink initially, and when it's exposed to oxygen because there is a leakage, this label turns to blue or purple.
And also these type of indicators are very useful for vacuum skin packaging application, vacuum packaging application, or atmosphere modified packaging with specific atmosphere control gases, MAP or vacuum conditions.
So in general, there are some advantages and disadvantages of this type of indicators. As advantages, we have to, they are easy to use, increase the safety of the product. It can be used to as a means of reduce the food waste, and also time and material cost of packaged food analysis methods. But as a disadvantage, we have that with applying these labels, we have an increase of packaging cost. And also the companies are worried because there can be a negative change in the purchasing behavior of the consumer, because they are, if there is, for example, for a freshness indicator, if the indicator changes as the freshness of the product is lower, so the consumer, they think the consumer are going to choose always the product that more fresh, that is more fresh. So they could be more food waste in this case. So also it is not possible to rely 100% on intelligent packaging for an optimal product quality, because there are several factors that are responsible for quality loss, as temperature, light, or mechanical stress, for example. And monitoring a single parameter cannot provide a complete view of the quality status of the product. So it is important to improve the robustness of the systems and combine different packaging technologies to exploit all the possible benefits of this intelligent packaging. And this is many of the points that made that intelligent packaging systems are not yet widespread in the market. Now, there are different integration methods to these tools that we are explained to apply to the packaging, and we are going to be to see some examples. For example, all of them can be applied as a form of a label, but there is also another integration methods as direct printing, laminate, encapsulate, immunolabeling, injection, that can be applied to, for example, RFID or MFEC. And we are going to be how to do this with some examples.
To make the packaging intelligent, you have to apply the intelligent label, the sensor on the packaging itself. So, for example, this is an example of a RFID tag applied in a tertiary packaging. You can see a pallet, and this pallet is plastic stretch film wraparound. And this plastic stretch film has a conductive ink that is the antenna of the whole tertiary packaging. That this antenna is connected to the chip that is on the base of the pallet, and it's a tool to for example to monitor if somebody open the whole pallet. If you take a box, because this box has a value product, you have to cut the plastic stretch film and you cut the antenna. When you are going to read the product, the pallet, you cannot read it because the antenna has broken. So you know if something has happened to this tertiary packaging, if for example, for anti-tampering, anti-proof opening of the pallet, also a track and trace tool as an RFID label in the whole supply is an example. Also, you can print the antenna in the packaging itself. For example, in corrugated boxes products, you can apply the antenna and then stick the silicon chip with conductive adhesives, and you have the RFID tag and something like hybrid. You have print directly the antenna and then stick the chip. This is also an RFID tag that is applied to the packaging, for example. You can laminate it in different plastic or cardboard materials. The NFIC, the tag embedded in the material itself is another way to use it, laminate it. You can, for example, in RFID tags, you have these examples, and you can apply the RFID tags in the different layers of the corrugated boxes. For example, this kind of boxes has different structures of different cardboard materials. So embedded in the material itself, in the different layers, you can apply the RFID tags, and it's more protective. The embedded of the tag is more protected against manipulation, environment, but you for example, and the difference for sticky label is that you cannot remove. Also, you can apply the RFID in the different parts of a box. For example, in this box, you can apply stick it as a label, it's stick it in the different folders, parts, and it's something like this high. This is another solution for RFID, and this is similar, another applications, another example, embedded in the different layers of the corrugated box is the RFID tag, or, as I said, printing the antenna and then adding the silicon chip. You can also encapsulate the sensor. For example, this is an example for fish industry. For fish industry, you can embed the RFID tag in a polyethylene disc, and then later on this disc, you embed it in the plastic container, plastic wool container, by friction, welded by friction methods that by heat, the plastic welded and gets together with the plastic box. This is an example for fish industry to apply RFID tags in wool containers. Also to apply the RFID in different elements that are going to use in a pallet in different points. This is a plastic pallet, and embedded the RFID tags in these cylinders, and then the cylinders are put in the pallet. So this is an example of embedded in plastic pallets. And also, this is a container for fish products, and in this container, a specific place to put the RFID sensor was designed. Okay, so you can put the tag in a specific place, and then you put a cap. After putting the capsule, the RFID is put enrolled in a capsule, and then you add the capsules in this type of tube. Okay, it's another way of integration, the RFID in the packaging. And also using immo-labeling for plastic products like wool container, pallets, and also individual plastic. You can use the immo-labeling. Nowadays on the market, you can find, for example, the queso feta cheese, or mozzarella. You can use this. You can see on the market these plastic trays, and the label, the graphic label, is embedded in the plastic. It seems like a label, but if you want to take it away from the plastic, it's not. It's embedded. So this is the same as RFID. You can embed an RFID tag in a plastic wool container, pallet, or even individual packaging in this way, that is specific for plastic materials. And also you have some some other examples on the market using putting the RFID tag in the artificial cork cap for wine, for bottling. This is also injection in the plastic cap, in the artificial cork for plastic. And this is another example. And another example for pharmaceutical products to embed RFID tags that there are a lot of examples of embedding RFID tags for treatments for patients, adhering treatments, and that's the reason in plastic they are embedded with using injection molding or immobility. And more or less that's the different integration methods you can apply as a label, printing directly on the packaging, making some hybrid, sticking labels, or using immobilizing or injection. And we have reaching the end of the presentation, and we want to conclude that all the devices we can apply to packaging are very related with digitalization nowadays. Even the visual indication, because with the visual indication, you can also read the camera of the status of the different colors in the visual indication and digitalizes the information. So nowadays, we have in our SUREFISH project, we have the platform, the blockchain. Nowadays, the digitalization is a reality, and even is making day by day more higher. And also we have a reality about sustainability. We have a lot of companies take into account the Horizon 2030 we have in Europe about recyclability, reuse, compostability of the packaging materials. Even the food waste is very in line with sustainability. So using intelligent packaging with digitalization support and also using as a tool for prevention food waste, we support all these issues in line with the directrices from European Community in 2030 about sustainability issues, no food waste, no emissions, or low as much as possible. So the intelligent packaging can also support in all these challenges. So I hope that the webinar was interesting to you, and we are open to questions, if you have some questions and comments, because we have thrown away a lot of information. Of course, this presentation will send to you and also the recording, but we are now all together. So if you want to go to a point that is not clear during our exposition, feel free to ask right now. We have time to questions. Yeah. Do you have some questions, comments? Salua, tell us.
Good morning. Thank you very much for the presentation, both presentation. And I think this training or this seminar is dedicated to the enterprise, to pilots, but also to researchers who want to have an idea about different kind of tools used for the traceability. And
this is a webinar, a general webinar about intelligent packaging, traceability, cold chain monitoring. It's didactic in some way, but of course for the pilot companies, this is now for the consortium, but it's open to research centers, to everybody that is interested and who wants to know more about intelligent packaging. That was the purpose of this webinar.
Yeah. So for the special case of seafood in general, and are you suggesting to For each type of pilot, we can use different tools for intelligent packaging. I think so. If we are going to look to freshness of seafood, we can look to some indicator of fish freshness.
Mhm. Yeah, it's up to the companies. Yeah, that's the point that we have mapped. More focus in SUREFISH in temperature abuse. So that's the reason we have tested commercial TTIs and also the data loggers. So SUREFISH pilots are more focusing called supply chain traceability, using different TTIs that are ready to be on the market and using data loggers or devices to monitor temperature. But it's more focused to temperature because for seafood products, fish products, we can develop a freshness indicator for spoilage, but it's another project itself because it's very specific and also it depends on the packaging because for example, it's more worth to develop in an individual packages wrap around because you can monitor the atmosphere and these kind of things. But as far as I know, in this project, we have developed the platform, the blockchain platform by ITENE that is going to check in the different pilots, but also for the companies, it's also available to test TTIs, data loggers. It depends on the company at the end. That's the point. We have also developed for the pilots during this month. Let me check. Carmen is going to share right now a specific brochure that we want to show you, taking advantage of the webinar about the technologies in SUREFISH. And we are going to share the one moment. We are going to share the brochure we have developed this last month. It's open or no? So let me check if I can. Can you see this? Sí. Okay. We have with the demo trials we perform in our simulation labs, we have developed these protocols for time temperature indicators for this type of labels. This is the protocols that a company has to follow. For example, we have tested in SUREFISH this monitor mark, this check time strip check time temperature, and also the fresh check temperature. So this is the protocol they have to use if they want to monitor temperature abuse. Later on, you have to check the requirements of the label because, as Carmen explained, some labels need to be before to use in the frozen, in the freezer, or in the fridge. So depending on the label, they require a specific activation, or you have to press a button and then stick it, the TTI label, in the packaging itself. This is the time temperature protocol, and after receiving the product, you send the product with the TTI activated, and when the product arrives to the final point, the final point has to check or interpret the visual responses and give you feedback. This is, for example, a very simplified.
This was applied for tuna?
This is imagine to put it beautiful, but you can apply for all the fish products. At the end, we want to split this in a very general overview. You check the TTI, You activate it, you stick it on the label, you stick it on the package, but it's tuna, it can be salmon if you want, it can be all the products in SUREFISH, even more, because it's a temperature label to detect abuse, even in meat, in perishable products. The data logger devices, this is the other protocol. Choose the proper, because there are a lot of data logger devices. As far as I know, the Don Marie has to want to check TTI, a data logger. You place it in the fish boxes, and later on, they record during the period, and later on, when they arrive to the other step, you ask I don't know if you want to complement something, Carmen.
Yeah, you have to ask the receiver point that send that device to you again, because you need to retrieve the data that has been recorded in this device. And you can also collect this data via using a computer in a CSV file or an Excel file, and you can use this data to represent graphically the temperature points and see if it has been a block of the whole supply chain.
And also, I talked with Inge, Rodrigo, and Alvaro about they can also put the data of temperature of the data logger in the blockchain platform in our platform also. And regarding anti-tamper-evident label, it's a type of label that gives you a visual indication of something has opened the packaging. So we have found different anti-tamper-evident labels on the market, and this is very easy to choose the right one, to attach it on the packaging itself, and something. Some of the anti-tamper-evident labels put it on the boxes that has a tab or a cap, and you put the label, stick it between the box and the cap in order not to be open. These kind of things. This is a very visual indication as a protocols that we have developed here in order to be for the companies in the pilot. This is something like protocols. We want also to take advantage of the webinar in order to show you also this part.
We will send this to you also.
Mm-hmm. Do you have some more question, or do you want to comment something? Or
so because, for example, for the Don Marie, it's going to have a marinated anchovy or sardine in jars and boxes. So he will use also TTP for it can continue the packaging.
I don't understand you properly, Salwa. What do you mean?
The Don Marie is doing marinated anchovy or sardine. So that means that he will put the product in jars and then in boxes that will be stored until it will be sold. So, I mean, my question is, also for this step, he's going to use the same temperature.
The interesting point here is to use the cold devices to monitor the distribution steps, or not only for storage, because for storage it's if the product has to be stored in frozen in conditions or in freezing condition, it's if you have a good practices, you have a climatic chamber, you have a freezer, so it's obvious that you are going to use cool technologies in your company. These tools are in the different, when you launch the product outside of the company and you want to monitor, not for storing. So it's to monitor the different steps of the supply chain. You can use for storing, but if you has a registers of the temperature in your freezers, in your climatic chambers, it's obvious that everything is going well. These tools are more useful for the distribution steps when you deliver your products to external companies, to external transport, and you don't know at the end what is happening. That's the point.
Mm-hmm. Yeah.
We have a specific meeting with Idon Marie afterwards. We have to speak more in detail in the specific meeting. Yeah. I hope that the webinar and these protocols were interesting to you. I hope you know something more about intelligent packaging.
Yeah.
Let me know if you want something more, if you have some question. Simona, what do you think about the webinar?
No, I think that it should be put online because it was really interesting, and I think that not only the pilots in SUREFISH, but also everybody can learn from this because it was very comprehensive. Thanks for organizing it.
A pleasure. I hope that more or less with our English has understood properly. Yeah. Okay, if you have another question, we can close the webinar and we can continue it
with Idon Marie.
With Idon Marie, and also with the webinar planning, we check with INGE, with all the companies the planning, and we can after summertime, because now it's reaching the complicated dates, but yeah, or probably in the next meeting in Tunis in October, we can also.
Sure, yeah.
Okay, so a pleasure to be with you during these hours, and we'll continue it. Speaking of.
Thanks a lot, Nuria, ITENE team.
Thank you.
Thank you to all of you. Thank you. Have a nice summertime if we don't speak, okay?
Okay.
Thank you.
Thank you.
Thank you. Bye-bye.
Bye.